Oh, I don't understand why that's not on my screen up there. So maybe I hit the wrong button. So 1 second, guys. I'm recording, but okay, this is a continuation of the Chapter 6 test review for our test tomorrow. We already did all of this yesterday. And today we're going to finish up, and we're actually going to fill in all the properties we can think of on the last page of our ISN. So we went 32 and we were on 33, correct? All right, here we go. ABCD is a rhombus. What do we know about a rhombus? Diagonals are what? You should know that like lightning, okay? Diagonals are perpendicular. Okay, I know I've got some right triangles here. So let's see what they're telling me. They're saying if EB is 9, that's here, AB is 12, angle ABD, that's here, is 55. Find each measure. So I went ahead and put everything they gave me on the figure. It said to find A to E. Well, A to E is not 9 and it is not 12. You're right. Thank you very much, Sterling, that we are going to need to do Pythagorean theorem. And that's one reason we want to realize or think about immediately that the diagonals of a rhombus are perpendicular. I'll draw you what I'm talking about here. This triangle right here is triangle AEB with A at the top, E at the right angle, B at the bottom. 9 is on side EB, 12 is on side AB, and that AB happens to be the hypotenuse of that right triangle. So if we want to find the length of A to E, let's call it X. The legs squared and added, X squared plus 9 squared equals 12 squared. That's the math we need to do. 9 squared is 81, 12 squared is 144. We would subtract 81 from both sides, giving us x squared equals 63. We would take the square root then of 63 to find the answer. Now, if you type on your calculator the square root of 63, so you should be getting about 7.9. Okay. So I got 7.9 for the length of A to E. I'm going to go ahead and put that on my picture. Is there anything else that's 7.9? If that's, remember the diagonals bisect one another? So CE would be 7.9, and I'm getting asked that right down here. Now, not that I had to do that question then. All right, so it says find the measure of angle BDA. BDA, that's right here. What is that angle? It's 55 because the diagonals of a rhombus bisect opposite angles. So that's 55, this is 55, and this is 55. So 55 degrees was the answer for 34. Now it says to find the measure of angle ACB. ACB. Well, you got a bunch of little right triangles here. If that's 55 and that's 90, we're going to do triangle angle sum. 180 minus 55 minus 90. Let's see, what's that? 145. So it should be 35 degrees. Yes, you guys calculate it. Make sure I'm right. All right. You should have a calculator open right now. You should be participating and practicing through this with me on all the calculations because that's going to help you remember things tomorrow. Just saying. I just see a lot of people who lay there waiting for other people to get the answers. You should be trying to keep up or get ahead. All right. 37 and 38, we got quadrilateral ABCD as an isosceles trapezoid. First thing you should think about when you think isosceles trapezoid is that the sides that are the non-parallel sides are congruent. So AD is congruent to BC. Now it says down here, which angle is congruent to angle BCD? So I got to find that angle, BCD. That's here. What angle is congruent to that one? Yeah, that one, ADC. Because the base angles of the isosceles trapezoid are congruent. Which side is parallel to AB? Well, that was simple. That would be BC. Do not miss questions like that. And then there's another question. It says, which segment is congruent to AC? Well, AC is a diagonal, and what you should remember as a property about an isosceles trapezoid is the diagonals are congruent. So BD. Pen stuck. Come on. Oh, it went way over there. BD. All right, 40 and 41, and I think 42, yep, have to do with quadrilateral MNOP, which is a rhombus. Angle MRN. Oh, wait, where's MRN? Oh, that's here. That should be 90 because the diagonals of a rhombus are perpendicular. We need to remember that property. If PR is 12, find RN. It would also be 12 because the diagonals bisect each other. And 4, if PON, angle PON, that's this entire angle here, is 124 degrees. Find POM. Well, these diagonals are bisecting opposite angles. So half of 124 would be 62 degrees. So that's the answer to this. Okay, 43, it says find the measure of each, find the measure of GH. We're going to need to do, well, first of all, this thing is a kite. What we know about the diagonals of a kite is they are perpendicular. We have to work with this little triangle, which is a right triangle, which means I have to do, again, the Pythagorean theorem. Okay, so we're going to do x squared equals, that's the hypotenuse. X squared is equal to a leg squared plus a leg squared, 12 squared plus 15 squared. 12 squared is 144, 15 squared is 225. When you add them, which is probably what you typed, you get 369. Take the square root of that, and that's about how much? Okay. 44, find the measure of angle Z. What you have to remember about this isosceles trapezoid is base angles are congruent. That one's 112. So let's say you were asked for X, it'd be 112. But he didn't ask for X, they asked for Z. What do you know about the angle W and the angle Z? What do they add up to? Because they're on the same side, consecutive on the interior, okay? So those add up to 180. All right, so you do 180 minus 112, and that will be the measure of angle Z. Is that 68 degrees? 45 is talking about, oh, this has got find each measure, find angle D. Well, this is showing that this is a kite, or you might just remember, a four-sided figure's angles add up to 360. And the way we learned or found the angle measures was 180 times the number of sides minus 2. That's 180 times 2, which is 360 degrees. Now, in this shape, which is actually a kite by consecutive sides are congruent, angle D and angle G are congruent to each other. So if we got a total of 360, we need to subtract out 67 and 49 from that, which is 200 and what? 244 degrees. And you can't have those angles be 244. You got to share it between the two. So what do you need to do? Divide by 2. All right, so they're 122 degrees. Okay, this S is a mid-segment. It really should have shown us that this was a mid-segment by showing those markings or telling us that R and S are midpoints. But anyway, the point is, how big is PO? Well, look, 16 to 12, what do you do to get from 16 to 12? Add or subtract? Okay, so the difference is 4. So do it again. We got to go down 4 more, and we're at 8. 12 minus 4, 8. The mid-segment is half the sum of the bases. You could double check that. 16 plus 8 is 24. 24 divided by 2 is 12. Which of the following statements are true or is true? Which is true? Must mean there's only one. All rectangles are squares. Is that a square? No. Okay. So that's not it. All rhombi are squares. No, some of them look like that. So no. All rectangles are parallelograms. Are the opposite sides of a rectangle parallel? Absolutely. All parallelograms are rectangles. No, they're not. Okay, you should know that one pretty well. 48, we got quadrilateral ABCD is a parallelogram. Find the value of x. You have two methods to which you can do it, and both of the ideas result in the same equation. You can either say consecutive angles are supplementary, so those add up to 180. Or you could say, well, wait a minute, I see it as alternate interior angles. Come here, highlighter. If you see it as alternate interior angles, you may be looking at this and saying, I can put 45 here. And then I will have a triangle whose angles add up to what? What do the angles of a triangle add up to? 180. So no matter what you do, this plus this plus this is 180 going that way or inside the triangle. So 85 plus 45, that's 130. And we subtract 130 and get x is 50. Okay, 49. Graph QRST to determine what kind of parallelogram you made. 12, 0 would be right on the x-axis. That's Q. 6, negative 6, R. 0, 0 for S. And 6, 6 for T. All right, it's telling us we got to prove what it is. We got to figure out what this thing is. What do you think? What is your guess? Looks like it might be a square. Okay, but to prove that it is a square, let's find the slopes. Slopes can tell us a bunch of stuff. To climb from S to T, we go up 6, right 6. Slope of ST is 6 over 6, which is 1. The slope of T to Q, down 6, right 6, which is negative 1. These are opposite and they are reciprocals. Since they're opposite reciprocals, that means those lines are perpendicular. So sides are perpendicular, which means we have right angles. Now I'm just going to double check for the others. SR, down 6, right 6. And RQ, up 6, right 6. All right, so those verify that all the sides. And now look, you see how you got 6 to 6, all the 6s? You can find the lengths of the sides. The lengths of the sides are all equal. They're all the square root of 6 squared plus 6 squared. That's how you can do it. It's like Pythagorean theorem. 6 squared plus 6 squared gives me the square root of 36 plus 36, which is 72. So all of the sides have the 6s. See, even when you square a negative, you get a positive. So all of them would come out to the square root of 72. So if all the side lengths are square root of 72 and the sides are perpendicular, this thing is definitely a square. Congruent sides, rhombus. Right angles, rectangle. Rectangle and rhombus makes a square. Okay, you got perpendicular sides, so you got right angles, and all the side lengths are the same. 15. See what we got here. Negative 2, 4. Q. 5, 6. Get these points plotted. 12, 4. 5, 2. Okay, when I see the points that I just got, I'm thinking, no way this is a square. but of course we will verify. Looks like it might be a parallelogram or a rhombus. All right, let's do slopes. It's fast to do on a grid. Slope of QR. You go up to right 6. 1, 2, 1, 2, 3, 4, 5, 6, 7. No, it's 2 over 7. R to S down to right 7. ST up to right 7, or TS. And QT down to right 7. All right, you see how all of these numbers are 2s and 7s? They're going to have, all the sides are going to have the same length then. So, but these slopes are not, they're just opposite sign. They're not opposite and reciprocals. So I have no right angles. I know this tells me it's a parallelogram, but what kind it is, the distances, all right, are all the lengths, all sides equal the square root of 2 squared plus 7 squared, which is 4 plus 49 square root of 53. So it's a rhombus, all equal sides, but not a square. Okay, we got 8 more. Find the length of diagonal SU. I'm going to do that by counting again. SU, you go up 1, 2, 3, 4, 5, 6, and right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the length of SU is the square root of. You can just do Pythagorean theorem, 6 squared plus 10 squared. Pick the square root. That gives me the square root of 136. My pen stuck. There we go. All right, that's about, I don't know, can somebody tell me what that is as a decimal? 11.7? Okay. Oh. It is 7? Yeah. Ooh. 11.7. All right, that's all they asked. I don't know what that's going to help me with at this point, but I know the length of that diagonal. Ooh. Find the slope of RU. Count up what we just did. Up 6. Wait, 1, 2, 3, 4, 5, 6. Right 2. 6 over 2 reduces to 3. Find the length of RU. Oh, all right. That's the square root of 2 squared plus 6 squared. That's 4 plus 36. We got the square root of 40. Am I going too fast? You okay? All right. Now, what's the midpoint of SU? Midpoint of SU, I got to write down the name of these points. S is at 1, 2, 3, 4, 5, 2. U is at 1, 2, 3, 4, 5, negative 5, negative 4. In the classroom, do you see a place where the midpoint formula is? It's a little hard to see. If you ever want to look on the wall, you can. Yeah, it's the pink one up there. You've got your slope formula over there. You've got your distance formula over there. Don't forget they're there. All right, midpoint formula tells you to add your x's, divide by 2. We've been over this probably 100 times. Add your y's, divide by 2. X's are 5 and negative 5. Y's are 2 and negative 4. Make sure you add before you divide. So we got 0 divided by 2 and negative 2 divided by 2. So our midpoint is 0, negative 1. What's that? Well, no, I was supposed to verify that it's actually right here, and it is. Point P is the midpoint, and it was 0, negative 1. We need to know how to find it, though, and it might not be drawn. Okay, now, is that the midpoint of RT also? It is. Okay, so that tells me something. The diagonals are bisected. So what type of quadrilateral is our STU? Justify by using properties and or definitions of this type of quadrilateral. Okay, It is, these sides are parallel clearly, right? Because opposite sides are horizontal, all right? These have the same RU. What was the slope of RU? 6 over, slope of RU is 6 over 3, which, no, it was 6 over 2, which was 3. And ST is also, has a slope of 6 over 3, or 2, and that's 3. So these are parallel. Okay, so opposite sides are parallel. Now, these slopes are not reciprocals or anything, so there's no right angles or anything. And the length of this side is 1, 2, 3, 4, 5, 6, 7, 8. And this side's also 8, but what was RU? Look on your paper, we found it already. It was the square root of 40, wasn't it? All right, so this thing is not a rhombus, so it's only a parallelogram. Opposite sides, the sides are not all congruent, so it couldn't be a rhombus, just a parallelogram. Okay, which formula or formulas do you need to use to prove that quadrilateral forms a parallelogram? We've definitely used slopes. Have we used anything else? Distance and, so it's all of these. So the best answer is B. You can do distance formula to prove opposite sides are congruent or diagonals are congruent or something. You can do slope formula to show opposite sides are parallel, and you can use midpoint formula to find out if the diagonals bisect each other. State 2 things that are true of a rhombus that are not true of a generic parallelogram. Okay, so you said all sides are congruent. Okay, that's true. All sides in a generic parallelogram are not necessarily congruent. In a rhombus, yeah, they are. This might have had 2 congruent sides there and there, but those would not be. All sides are congruent. What else? We've got multiple things we can write. All sides are congruent. You're learning yours, Darylyn. All right, now the diagonals of a rhombus are special. They are perpendicular. They aren't in this thing. Okay? So diagonals are perpendicular. Okay, that's true. There's one more I'd like to think of that most kids probably would, they'd probably choose these two to write down. Do you remember what happens here and here? And here and here? The diagonals do what? If I heard it, bisect opposite angles. Bisect opposite angles. All right, so in this figure, those angles are congruent, and these are congruent to one another. But not in that one. This one, it goes like this. Oh, wait a minute. Dum, dum, dum. Double. Anyway, they don't bisect. Those diagonals don't bisect opposite angles in a parallelogram. You didn't have to write all that. That was just stuff I was trying to help you see. 58. State the properties of two kites. Oh, two properties of a kite, not of two kites. What do kites have? Cadence? Good job. All right, diagonals are perpendicular. What else does a kite have that something else doesn't? Special. Good, Chloe. Okay, two pairs of consecutive sides are congruent. Okay, that's good enough. I mean, that's the two I think that you would bring up. It has a line of symmetry. There's more things you could say, but that's enough. All right, if the diagonals are congruent, then this thing, that parallelogram must be a rectangle. If the diagonals are perpendicular, it has to be a rhombus, and if they're both, then it has to be a square. That's just a little aside. Okay, this time, want to see, oops, that's not the one I want. You go to the back of your ISN. I'm going to see if I can't put some stuff on there for you about the properties. I'm going to have to go fairly quickly. I don't think I'll get all of it in, but let's start with the top. I just wanted you to remember that if it's a four-sided figure, what do the angles add up to? 360. Okay, four-sided figure, angles add to 360 for a quadrilateral. I know that's only part of the picture on the back page. I thought, what the heck, maybe you want to write that down. Put in the diagonals, please, on the kite. Show that there's a right angle in the middle there, which would give you 4 right triangles. Show that the short diagonal is bisected with single slashes. And you can show that consecutive sides are congruent. So I'm double slashing the top 2, triple slashing the bottom 2. The long diagonal bisects. I don't like how that's really not in the middle. There. Oh, kind of annoying for me to be a perfectionist like that. Okay. The top long diagonal does bisect this angle up here and the one down here, but they are different. There's some more markings I could do, but it kind of gets super busy on this thing. If you want, we could triple mark that these angles here are congruent to one another. And then if you put one arc with a slash in it, these angles right there are congruent. All right, so you got some little congruent right triangles at the top and at the bottom. And if I put on here, I know this isn't technically correct for me to say angle A and angle B, but if those ginormous angles there are congruent to one another. Okay, you would know what I meant. I'm not meaning if you add that angle and that angle, obviously they would be the whole angle there. Technically, I should use 3 letters, though. All right, let's talk about the trapezoid. You know that that has one pair of parallel sides. And I'm going to label this one pony so that I can say angle P plus angle Y equals 180. And angle O plus angle N equals 180. Because those would be consecutive supplementary. That's really all you need for that trapezoid. Does anybody still need this? I can wait. Okay. Okay. Now we're going to jump over to the parallelogram. Put in the diagonals, please. We should know that the diagonals bisect each other, so I'm going to single slash the shorter one, double slash the longer one. And we know that opposite sides are parallel. I'm going to double arrow on the top and bottom. And then I'm actually I'm going to triple slash it. And then the left and the right, of course, I'm going to single arrow for parallel, and I'm going to put 4 slashes. Okay, if we called this one ship, I think you guys should know that consecutive angles are supplementary. I don't really know if you want to, you could write that down if you want, if you know what that means. I don't want to use those letters incorrectly. I guess I could have said angle S plus angle H plus angle, and those two add up to 180, these two add up to 180. Now, there's also some congruent angles in here. This angle is congruent to this one down here. So alternate interior angles are congruent. This angle is congruent to this one over here. Those two. And then you can go that way also. 1, 2, 3 arcs up by the H here. And then down here at the bottom by the P, 3 arcs. And then I got to think of something else to mark this other one. I just don't feel like doing 4 arcs. So I'm going to do an arc with a slash. Arc with a slash. And then I'm not even bothering with the vertical angles. You guys know about vertical angles. Obviously, these two are congruent and those two are congruent. All right, let's move on. Try to finish this off. We've got a rectangle, drawing the diagonals on the rectangle and on the rhombus. Okay, on the rectangle, we know that opposite sides are congruent. Well, let's go ahead and discuss these diagonals. These diagonals are congruent. So that would mean that all 4 of these pieces, since the diagonals bisect each other, all 4 of those pieces would be congruent. And then, of course, the top and bottom are congruent. Opposite sides are congruent. And that's just, true of any parallelogram. Let's call this one FOLD. I don't know why I'm picking 4-letter words. Anyway, fold. What we know about all the angles, and I'm going to be technically incorrect because I should use 3 letters to name these, but angle F, every corner. Angle F equals angle O, which equals angle L, which equals angle D, and they all equal 90. Now, something important, the diagonals do not bisect angles, so this angle, but these 4 angles here are congruent to one another. So that one up at the tippy top, those little isosceles triangles, you have base angles that are congruent. And then on this side, these 4 angles are congruent to one another. Okay, the properties of all parallelograms, which a rhombus is a parallelogram and a rectangle is a parallelogram, still apply. So whatever we put on the parallelogram, there's just some more special stuff that's on this rhombus. All the sides are congruent. I don't know why I'm double slashing, probably because I'm going to use the single slash where the diagonal was bisected. Property of the rhombus, diagonals are perpendicular. If you'd like to put 4 right angles in there, you've got 4 congruent right triangles. Because the diagonals bisect opposite angles, these 4 angles are equal to one another. And then going to the left and right, those 4 angles are equal to each other. Don't forget that since you have a right triangle in those figures, that you could be able to use Pythagorean theorem, a squared plus b squared equals c squared. Okay, and the last thing I want to say about a square, and we'll be finishing up here and just take us 1 more minute. You got time. Oh, I forgot to do that guy, didn't I? Sugar. This one's pretty important. I think you know a lot about a square. The diagonals are congruent. So these pieces equal one another. And then the legs are congruent to each other on the isosceles trapezoid. One very important thing to remember about an isosceles trapezoid are the base angles are congruent. So that whole angle up there is equal to that one over there. And down here, those base angles are congruent. Okay, so if I label this ABCD, give me 1 more second. DB is congruent to CA. Okay, if you want to mess around, the only thing I want you to know for sure about a square, diagonals are perpendicular, and these angles are all 45s, okay? Anybody who wants to finish that, I'm finishing that up right now. And you know there's right angles in the corner. Okay? You don't have to make it right, all of these. study for your Chapter 6 test.